Okay, so let me see your lights for number 17. I didn't give you lights. I'm so sorry. Skipped your whole table. You sound so sad. You didn't give us lights. I'm so sorry. Here you go. All right. What do we got here? Well, we're nearing the end, yeah, and some people may not have finished, so that's okay. Let me see what you got. On the real thing, though, are you going to leave anything blank? No. You watch your time, and if you're running out, you just start picking letters and typing in random numbers on stuff. Who knows? I mean, you're less likely to get it right on a fill in the blank one, but you never know. I mean, there's still a 1 in a bazillion chance. All right, so what am I seeing? Are you playing with those over there? Or I couldn't tell. All right, so we got a couple different here, and a lot of you didn't get to it, and that's okay too. But as we look at this one, okay, if this was more difficult, because I would imagine most of you probably did this one by hand. And remember too, if you're putting absolutely everything in Desmos, even when you don't need to, that's going to eat up your time. So even though you could, or if this one was more complicated, you could type this into Desmos, and then you could type all of these and see which one matches. Am I hearing things? Okay, I can't always tell when I'm talking. Hello. Oh, okay. All right, you're fine. Okay. But that takes time. But if that's the only way you know how to do a question, you do it, right? But if I take 8x cubed and subtract x cubed, that's going to give me 7x cubed. We all agree with that? So I can eliminate those two very easily. And then 8 minus a negative 2 means we're going to add. Our answer is B. So that's 17. It's not at the very beginning and it's not at the very end, but I wouldn't say it's crazy difficult, right? It's totally doable. Okay. So I don't want you to also get in your head that just when the numbers get higher, they're going to be more complicated, then you can't do them. Don't be thinking about that either. Okay. Number 18. Let me see what you got. That's good. That means you were using your time wisely probably and was like, okay, let me jump to the ones. And that's the other thing is if you see one and you're like, ooh, not sure what to do and your time is ticking away, do the ones you can do and then go back and quickly and then go back and spend more time on them. Okay. This one looks good. I would say most of us probably just did this by hand, right? So if I have 4 times the square root of 2x equals 16, that means the square root of 2x equals 4. How do you undo a square root? Square it. So we square it, we get 2x equals 16, x equals 8. I'm honestly surprised that 8's not an answer. Because don't you think some people would get that and be like, whew, 8, bet, let's move on, right? Okay, but I want 6 times 8, which is 48. Okay, we good on those? I'll take that as a yes. All right, now number 19. For which of the following tables? This one, I would totally suggest Desmos. So let's all do this one together. Even if you've already done it, because you did it in Desmos. We're going to type in 2x minus y, 2x minus y, right? And that is greater than 883. And then I'm going to zoom until I can see my line. Then I'm going to type in a table, and the tables are all very similar, so I can just do one and then I can go adjust it. But this is 440, and then 441, 442, 0, -2, -4. All right, so the way that I zoomed it, have y'all typed this in? No, because you've been talking the whole time. Type it in. The way that I zoomed it, they all look like they're stacked on top of each other. So I just need to zoom in more so I can see what's going on. And then I can see that those are not all in the, because it's asking me which are all the values of the solutions. So A, not my answer. The difference between A and B are that these two numbers get flipped. So I'm going to change that to 442. I'm going to change that one to 441. See, I don't have to retype it every time. Then B, not my answer. Then the difference between B and C, this will be 442, 440, and again, not all in the shaded area. So I really hope that D is my answer. Otherwise, I need to go back and reinvestigate something. Like maybe I typed the equation in wrong or something. But that should be 442. That'll be 440, and that'll be 441. And then you can see that they're all in there. Okay. So that makes your answer D. That's the easiest way to do it. Could you substitute them in and do stuff by hand? Absolutely. Do we need to know how to do stuff by hand? Absolutely. But if we're allowed to use Desmos, might as well use it. So our answer is D. Okay. Now, now listen, y'all stop talking to each other. Stop it. Shh. I don't want to start splitting people up, but I will. This is driving me crazy. Even though this one we can do by hand, again, we can do it in Desmos. But in Desmos, you're going to have to play with the numbers a little bit, and let me show you why. So go ahead and type that in. I'm going to refresh. We know how to do a system, right? 5y, be typing, equals 10x plus 11 and negative 5y equals 5x minus 21. Okay. So here's our solution. The problem is, even though sometimes we can hit the little thing over there where Desmos will give us a fraction, this is not going to give us a fraction. And if I click off of it and it disappears, here's another little thing that you can do. I don't even know if you know you can do that, but if you do that, then the ordered pair jumps over there so that you don't have to keep clicking on it. It's there. But what I want is 30x. Okay, so my x value is 0.66667, right? So 30 times. Now, what is that decimal really? Like that's 0.66667, but what do we know that really represents? 0.6 what? Repeating forever, right? 0.6 repeating forever. That makes sense? So maybe we know what that is as a fraction. Like what is 0.3 repeating as a fraction? 1/3. So this really is 2/3, but maybe you don't really know that, and that's okay. But if it's repeating a whole bunch and then you have a 7 at the end, aren't chances pretty good that it really just means that it keeps on going? So if I multiply that by 0.6666, you see I'm getting close to something. If I do the 4 6s and a 7, I get 20.001. That is not okay for an answer. But if I keep adding the 6s, you see how it's getting, and I keep going and I really have the 6 repeating, my answer is 20. So I either figure out the fraction because that's what we would get by hand, and that's okay. It's totally fine if you did it 100% by hand. But be careful with the decimals when you can tell it's a repeating one, okay? And you're having to play with that stuff. If it was multiple choice, it'd be no big deal, but when it's free response, that's a different story. Okay. What questions we got? We good? All right. All right. Here's one where you can't give me your lights anyway, but everybody pay attention. Because how many of you got this far but like skipped it or were totally unsure? Yeah, okay. All right, so listen. We've got a rectangle inscribed in a circle. So first of all, you have to know what that means. Here's a circle. Here's my rectangle inscribed in my circle. It goes on to say, even though it doesn't need to, such that each vertex of the rectangle lies on the circumference of the circle. Those words, totally unnecessary because that's what inscribed means. So I feel like they were very nice to tell you that. The diagonal of the rectangle is twice the length of the shortest side. So this is the shortest side. This is twice the length of the shortest side. Okay, everybody okay with that? Area of the rectangle is this much right here. What is the length in units of the diameter of the circle? All right, in order for me to find the area of the rectangle, I would have to know this side length. I know this side length, I don't know this one. I could do Pythagorean theorem with these two and figure this out, but I don't need to. If you see a relationship between the sides of a triangle, your reference materials that I'm assuming, I don't really know how it works on the digital version. I think there's a button you push and it shows it to you. Is that how it works? Okay. So on this, it's on the front of it, or probably your front page. But this is what you get. You will get this exact thing, no more, no less. But look at this 2x and x. If you see that relationship, that is a 30, 60, 90 triangle. So that means I know that this side length is x times the square root of 3, and I don't really have to do any work. So that means that this is x times the square root of 3. To find the area of this rectangle, I multiply this side times this side. So x times x square root of 3. That equals the area, which is 1089 square root of 3. You with me? This is a multi-step problem. It is not necessarily crazy difficult. It was just lots of steps. So x times x, that is x squared. So x squared square root of 3 equals 1089 square root of 3. So can I divide both sides by a square root of 3 and get rid of that? Yep. And then I can take the square root of 1089, and what does that equal? What's the square root of 1089? $33. Thank you. Is my answer 33? No. It asks me for the diameter of the circle. This is the diameter of the circle, right? It is 2 times x. So what is my answer? 66. Okay. There's not a ton of room to work here, but remember, you have all the paper you want. Now, I don't remember, there's proctor instructions for the SAT and for the AP exam, and I get them mixed up. On one of them, it specifically says you give them one sheet of paper, okay, to start with or whatever. But just because you have one sheet of paper doesn't mean that's all you get. You can raise your hand and ask for an infinite amount of sheets of paper. So don't try and save your root. Like if you're writing and drawing big, ask for more paper, ask for more paper. Don't try and, just cram everything on there. Draw pictures, write stuff out, ask for more paper, get a new pencil, whatever you got to do, okay? You cannot write on the tables. That's why I wanted you to actually write on this stuff here. I know on STAR we were able to give you those things, but that you can't do that on this, okay? Any questions about this one? All right. Let's look at 22. Show me your lights if you got to 22. I could probably guess what our two favorite answers are. Did most of you not even get here? Yeah, this one. Okay. All right. So rectangles ABCD and EFGH are similar. The length of each side of EFGH is 6 times the length of the corresponding side. Even on my paper, look, my paper has pictures drawn when I did it myself. If you don't have pictures drawn and you got there, shame on you. Okay, so we got ABCD. They don't even have to be to scale. I don't even care if they look congruent. But we got ABCD and EFGH. So let's say the side lengths are X and Y. All right. The length of each side of EFGH is 6 times the length of these corresponding sides. So this is 6X, this is 6Y. And then the area of ABCD is 54. What is the area in square units of EFGH? Guess what the answer isn't? It isn't 6 times 54. Yeah, nah, it's not 6 times 54. First of all, we're on number 22. You think it's going to be that straightforward? No, okay? And it's not like it's crazy difficult either. And this is why a picture helps you even on something you think is crazy simple. This right here, this area is x times y, right? This area is 6x times 6y, which is 36xy. This area is 36 times this area. Perimeter would be 6 times more. Area is 6 times 6 more because it is square units. Units squared. You got to square the factor there. If we're talking volume, then it would be 6 times 6 times 6. Does that make sense to you? And so drawing it out like that can help you decide, am I supposed to multiply by 6 or 6 squared or what was it? It's 36 times 54, which is 1944. Okay. The side links are 6 more, but if you have this is 6 times more, this is 6 times more, you end up multiplying those two together. Okay? We good on that? Don't fall into that trap. It's an easy trap to fall into. All right. 23. Let me see your lights. We got everything. Okay. And some of y'all, some of these colors make me want to disown you, right? Because if I had 3/4 plus 5, what would I have to add those together? Common denominator. Would that give me 8/4? 100% no. If that's not going to work there, it's not going to work here. You need a common denominator. What is your common denominator going to be? K. You got to multiply this by K over K. It's a basic fraction rule, okay? Nothing crazy. So this gives me 42A over K plus 42AK squared over K. Do we all understand where all that came from? Because you have to have a common denominator. That means I get 42, I'm going to put this in standard form here. So AK squared plus 42A all over K. Can I actually combine these two terms? Are they like terms? No. This is like 42x plus 42y. They do not have the same variables on them. I cannot combine them. I have two terms. I will continue to have two terms. That eliminates those two. Okay? So now, if to look like this, if I factor out a 42a, that will leave me with k squared plus 1 all over k. Now, here's a Desmos trick. Desmos might not like a and k in this situation, but you could let a equals x and k equal y and type it all in. You could do that as well. I could do that too, yeah. What, it worked for you though, right? What do you mean? Oh yeah, yeah. Perfect. That's great. All right, we good? Okie dokie. Oh, so which, that means my answer is D. Yes. On the SAT, is there like a no calculator part? Not anymore, no. No, not anymore. There used to be until it became digital, and then they let you use Desmos for everything. Yes. So calculator for the whole thing. Oh, and I may have told you at one point that we were going to hand out like handheld calculators also. And I don't know if I told you that we're not handing out calculators, but if you want to bring the yellow calculator also, because sometimes it's just easier to do the computations, or if you're more comfortable with it, you can totally bring it. You'll just have to make sure that you clear it, or the teacher will clear it for you. But you can use that and Desmos if you want. Or if you just want to use Desmos, that's fine too. Or you don't want to use Desmos at all. because the whole thing can be done without a calculator. The calculator isn't required on anything, but all right, let's look at 24. Which quadratic equation has no real solutions? All right, visually, what am I looking for? What would that mean for a graph? It doesn't cross the x-axis, exactly. So remember, for a quadratic, this is 2 solutions. This would be like 1 solution. Well, ooh, goodness, not that. This would be like 1 solution, and then this would be like no solutions, all right? So basically, you just type all these in. The nice thing is that they don't look, I mean, they're all pretty similar. So if I type in x squared plus 14x minus 49, I can see here that I've got 2 solutions. So my answer is not A. Then B, I just switched the, oh, I didn't even ask you for your lights, sorry. I just switched the minus and the plus here. Now, by hand, you could just factor all of these and figure it out, but who wants to do that? That takes forever. I have 1 solution there, so it's not B. Then C, I add a 5 here, change that to minus. I got 2 solutions again, so I'm hoping my answer is D. And then I change that to plus, and it's way up there, so there's my no solution, and it's D. And that's number 23. By hand, it's a more complicated one because it would take you forever, but that's not a difficult question, right? So remember, just because it's higher up in the numbers doesn't mean that it's crazy hard. But that's D. All right, 25. Let me see your lights. All right, what do we think here? Let me see your lights. I got red, blue, and green. Okay, so stay with me on this one. Ready? The function P models the population in thousands of a certain city T years after 2003. Okay, so you're going to put in the number of years that you have there. And then according to the model, the population is predicted to increase by 4% every n months. So listen, if you want it to increase by 4%, this needs to be equal to 1. Do you agree with that? Like, because if that is equal to 1, whatever that exponent is, after I substitute in t, then that exponent is 1, then this will increase by 4% because that's 1.04. You with me on that? So I need 6/4 t to equal 1. And Victoria, I can hear you in my head. Where the heck is in, right? That's what you always, but that's a good question when you read, where the heck, this variable is not even in there. I get that. But every n months, you're trying to figure out how many months that is. This is your time. It's the only thing that would even possibly make any sense, okay? So I have this. I need to figure out what t is, first of all right? So in order to figure that out, I need to divide by 4/6, which is really just 3/2, right? You can simplify that a little bit. And then I'm going to multiply both sides by 2/3 to get rid of that. So that means t equals 2/3. If t equals 2/3, then that means that this whole thing is going to equal 1, and I'll increase by 4%. You with me so far? T and n are not the same thing. T is the number of years. So I need 2/3 of a year, and this is talking about months. How many months are in a year? 12. So if you do 12 times 2/3, that gives you 8. Okay? That's okay. He guessed right. He can be proud of himself for guessing right. Does it make your head hurt a little bit? Ask me a question. Yes. Because if I multiply this number by 1.04, then this number that'll be 104%, right? That means this number increases by 4%. So it says the population in thousands of a certain city to year, okay. According to the model, the population is predicted to increase by 4% every n months. So I need to know how many months it's going to take for this to increase, which means that if this is 1, that's by increasing by 4%. If it's anything else other than 1, then I wouldn't have exactly 4%. Does that help? Okay. What else? Anything else? Okay. Let me see your lights on 26. This is another one where you have to use our noggin more than we maybe want to. What do we got? And I know a lot of you didn't even get to it, so. Okay. All right. 1, 2, 3. All eyes on me, because we can do this, right? This is a circle question. We could use the circle equation. We really don't need to. And so if I have this point here, or let me draw my circle. Okay. In the circle, it has a center. My center is at -1, 1. Okay. Then I have a point, there's a line T that is tangent to the circle at point 5, -4. Let's pretend like that's here. So this point is at 5, -4. And I have a line that is tangent to the circle right there. Okay, you can pretend like it's tangent. It's tangent enough for this example. So I have a radius here. Here's one thing you need to know from geometry for you to be able to, there's a couple things from geometry, is that when you have a line that is tangent to the circle, it is perpendicular to the radius drawn to the point of tangency. All that means is you have a tangent line, you draw the radius to where it hits the circle, this is perpendicular. Okay, we good with that? And then what we're looking for, this is line T. I need another point that's on line T, not on my circle, not on the line that includes the radius, none of that. But I only have 2 points. So the only line I'm capable of finding right now is this line. Okay, I can find that line and the slope of the line, the whole 9 yards, right? How are the slopes of perpendicular lines related to each other? Like parallel lines have the same slope. What about perpendicular? They're negative reciprocals, right? So like if I had my slope is equal to 5, then my perpendicular slope is going to be -1/5. Okay, they're negative reciprocals of each other. Does that sound familiar? Jenny, you with us? Because you can do this. All right. Now, can I use Desmos to help me write the equation of this line and find the slope? Absolutely. I totally can, right? So let's go over here and let's put in to our little table here, -1, 1, -1, 1, and 5, -4. 5, -4. And then I wanted to write an equation of a line, so what do? Push the little thingy. There's my linear regression. Okay. This is the slope of the line that goes through the radius. So do I actually want this slope? No, I want the negative reciprocal, right? So this is negative, which means it's going to be positive. And to find the reciprocal, I'm just going to do 1 divided by 0.833 repeating, right? And look what happens when I keep repeating my 3. It finally just gets to 1.2. So it's not an estimate, okay? So my slope is that I'm going to use is 1.2. Do we agree with that? Now, at this point, if at the very least you understand that the point you want is on the pink line and not the orange line, you can go ahead and I guarantee you at least one of these points is on that orange line. It has to be, right? I mean, why wouldn't they do that? Because they would think that maybe you're going to do that. So if I come over here, let's put in another table and let's put in those points. Let's put in all of our answers, okay? So my answers are 0 and 6/5 and 4 and 7 And because I would end up doing this anyway, but I'm just going to do it now instead of later. Okay. Oh, I'm a little shocked. I'm honestly very shocked that this is not. Oh, it's 11:1. Did I do it wrong? Oh, thank you. So maybe it is on there. There we go. No, it's still not on there. I am shocked that because I told them to try this in second period, but we didn't type it in. Did I get the rest of them right? Yeah. I would have bet money that one of those blue points would have been on that line. But if you now if you thought that was it, you're like, well, that can't be the right line, and I know I found the equation of the line. Whatever, it's not the line we really wanted anyway, right? So my slope that I'm really using is 1.2. I need to write the equation of the line that goes through this point because it's this line right here. So remember this y minus y1 equals m times x minus x1. And let me ask you this. If you have trouble remembering this, do you remember the slope formula? Y2 minus y1 over x2 minus x1, right? So if you think of it like that, y, and you just do y minus y1 over x minus x1, and that's equal to the slope. Look what happens when you just multiply both. This just comes from that formula. So if that might help you remember that. And we're going to use this point. So we get y minus a negative 4 equals 1.2 times x minus 5. That becomes plus a positive. And then we're going to put this in to Desmos in place of our other line. Okay, or I guess we can leave it in there. It doesn't really matter. But when I put that in there, I'll just leave it. And I'll do y plus 4 equals 1.2 times x minus 5. And then see, these lines are perpendicular because this line was on this point was on the circle. This is the point that is on that tangent line. Okay. Again, lots of steps, but doesn't mean that it is impossible for you. Okay. What questions you got? What are you doing over here? I'm just curious. Like, why do you have 2 lines? Oh, I'm just curious. I'm not saying you did it wrong. No, you told me to slope. Oh, because okay, got it. Okay. Oh, and that helps too. Yeah. Okay. All right. So that is C. We good with that? That'd be way harder to do just on that yellow calculator. Could you do all that by hand? Yes. Again, yes, but. All right, now this one. You really need to put on your thinking hats here and sit up, Jenny, because I know y'all can do this, but think about this. This is the end. This is the very last question because you do English, math. Very last question, and that is a ton of words. All right. But I promise, and there's a lot of words in there that make your brain want to hurt. And yesterday, y'all seen Back to the Future with the flux capacitor? Okay, so we rewatched that yesterday, and this says flux so many times, all I could think about was the flux capacitor. But these words in here repeat themselves, and they get a little wacky, but it's doable, I promise. Just got to use your brains. All right, so for an electric field passing through a flat surface perpendicular to it, the electric flux of the electric field through the surface is the product of the electric field strength in the area of the surface. Lots of the same words, right? When I read this earlier today, somebody goes, do we even need that first sentence? We need part of it. Well, really, you need all of it because it's got to tell you that stuff, but it makes you just that first sentence go, what? But it says here, all of that stuff is the product of the electric field strength in the area of the surface. That's an important part of that sentence. Okay, now we got to keep reading. That's just the first sentence. A certain flat surface consists of 2 adjacent squares where the side length in meters of the larger square is 3 times the side length in meters of the smaller square. So that's where I stopped reading and said, all right, I'm going to draw myself some squares. So adjacent means that they're attached. That may or may not actually be important to me right now. I'm not real sure. But the side length of the bigger one is 3 times the side length of the smaller one. Okay. That's what that sentence says to me. Then I keep reading. An electric field with strength 29 volts per meter. So remember, the product of the electric field strength in the area of the surface. So we've got 29 volts per meter, uniformly passes through this surface, which is perpendicular to the electric field. The total electric flux of the electric field through this surface is, 4640 volts per meters. What it's saying is this. This strength times this surface area gives me this. That's all it says. So I need this surface area. 3x times 3x is 9x squared. X times x is x squared. So the total surface area of that is 10x squared. Do we agree with that? And I also know that if this is the very last question, you don't necessarily have time to go back and reread and process, and you're already stressed out. But I do want you to just see that this is doable. Back up here, the product of the electric field strength and the area of the surface. So this is the electric field strength, 29. This is the surface area. So 10x squared times 29 equals 4640. Everybody with me? Because it's asking me, it's saying this is what happens when you use the whole surface. But then it asks, what is it just through the larger square? So we got to figure that out. And it's not multiple choice, so we can't like even make a good educated guess here. But if I have this, then this is 290 x squared, and that equals 4640. So what's 4640 divided by 290? 16. So that x is equal to 4. Is that my answer? No, unfortunately, but we're almost there. What we are looking for is the electric flux of the electric field through the larger square. This is the surface area of the larger square. So 9x squared times 29 is going to be my answer. So that is 9 times 16 times 29. And what is that? 4176. That's your answer. Don't just think, oh, I'm just going to skip one like that, because it may not be as wordy. Those words were mean. That's a kind of a mean question just because of the words. I'm not going to lie. But all right, we good? So y'all keep these now. These are yours. Also, if you go online, if you just, you can find it in College Board, but if you just do College Board, SAT practice, and make sure you're on College Board, they have digital versions that will give you feedback, which is really good as well. Great thing to do before Wednesday.